Okay, so we're doing the coursework, corresponding odd. We're on page 286. So we're doing 1, 3. We're on page 241. Sorry. I don't know which page and number I said. 241, doing 1, 3, 5, 7, and 9. So you're starting out with 5x cubed plus 6x squared minus 17x plus 20. Okay, so you should end up with this. We multiply by 5x squared to get all of this. We subtract this, we end up with minus 9x squared minus 17x plus 20. What do we multiply x by to get minus 9x squared? It's minus 9x. So then we have minus 9x squared minus 27x plus 0. So we multiply the minus 9x by x. By 3, we get this. Now, I brought down the 20, and so I still have that there. I subtract that, I get 10x plus 20. What do I multiply x by to get 10x? It's 10. So now I multiply that out, I get 10x plus 30. My remainder is just 10. Negative 10 is the remainder. So I write it like this. 5x squared minus 9x plus 10 minus 10 over x plus 3. Go on to the next one. When you get to 5, you're going to be working with a fraction. But you can do that. So for 3, you should have had this. You get some pretty big numbers in the end. You get 2x plus 5. We end up with all of this. Then we get this. What do we end up with? What did we multiply? 2x pi to get 10x cubed. It was 5x squared. What do we multiply 2x pi to get minus 18x squared? It was minus 9x. We end up with these big numbers. So we have minus 9x. That gives us 18x squared minus 45x. Minus 135 minus 45 minus a minus 45 gives us, we cancel those negatives, we get minus 90x minus 225. And what do we multiply 2x by to get minus 90x is minus 45. And you have a fraction in 5, so that makes it harder. Minus 4. In 5, you end up first with x squared. So And then, so first you end up with your x squared term in 5. And then you have, so you get 3x to the 4th plus x cubed plus x squared. And then you bring this down, so you have the first two terms cancel. Okay, so we have here 3x to the 4th plus x cubed, and then we minus 99x squared. Okay, so we have plus 0x minus 30. Minus 99 minus 1 is minus 100. Okay, so what do I multiply 3x squared by to get 100? Well, I set it up. If this is just the unknown, I'm just going to call it x. What do I multiply 3 by to get minus 100? Just solving for this x, you divide down. You get x is equal to minus 100 over 3. So similarly, what do you multiply 3x squared by to get minus 100x squared? It's minus 100 over 3. Okay? So what you're multiplying everything by is minus 100 over 3. Then you have to multiply all of that out, and you have to get your remainder. So you should have gotten this far. We have this. Multiply x squared. We get this. We get this. What do you multiply 3x squared by to get minus 100x squared? It's minus 100 over 3. And then you have to multiply that out. After you multiply that out, you get your remainder. So we multiply that out. Minus 100 over 3 times 3x squared is minus 100x squared, which is how we set it up. Minus 100x over 3 times 1 minus 100 over 3. Okay, now this is our remainder. Minus 100x over 3 plus 10 over 3. So this is our answer, x squared minus 100 over 3 plus 100x plus 10. I brought down that 3. They were both over 3, so I brought it down. 7 is easier than 5. Okay, so for 7, you have 4x squared plus 1. Get this. Your remainder is 11. 9 minus a negative 2. The negatives cancel. You get an 11. Okay, so let's go through 9. You should just have x plus 4. With this, you multiply everything by x, and then you multiply everything by 4. You get that. Your remainder is 6x minus 3. So this is our solution. We didn't talk about the lab. This lab is a complex one. So if you go to Files in Canvas, you will see Newton's Law Lab. So there, you can just press to make sure it's in alphabetical order. And scroll until you see Newton's Laws Lab. Open that up, and we're gonna go through. We're gonna go through it. Now, there's a lot to this lab. There's actually 8 graphs, 6 sets of data, and so we want to make sure that you understand it. Abigail, can you just read the first part? So we're going to read introduction. So your homework is corresponding even. You know that, right? 2 through 10. And then I already gave you your physics homework of finishing those exercises and starting your SP. So everybody understands the homework, right? Kyler, were you here when I said the physics homework? I think you were. Yes. Okay. All right, so let's just read up to constant mass. Okay, Abigail, please.
The purpose of this experiment is to learn the relationship between force and acceleration. Newton's second law states that the acceleration of an object is proportional to the force acting upon it and inversely proportional to the mass of the object. A equals F over M. Equipment is dynamic cart, spark timer, meter stick, pulley, and weight.
Okay, now we're going to read just the first part, experiment A. Caitlin Heim, can you please read that?
Constant force 1. Cut a 1 meter long ticker tape and pass it through the spark timer. Attach the ticker tape to the dynamic cart. The timer and the cart should be properly aligned and must be at the same level. Set the spark timer at 10 hertz mode. 2. Connect the cart with a mass of 50 grams to a pulley. Gently release the cart right after you switch on the spark timer and touch the cart before it hits the pulley. 3. Measure and record the distance between consecutive spark marks, as change in x1, change in x2, etc. Neglect the very first interval. 4. Calculate the velocity for each interval. V equals change in x over change in t. 5. Draw the graph v versus time. T is the horizontal axis. And determine the acceleration from the slope of the graph. 6. Repeat the steps 2 through 5 with a mass about 500 grams, adding to the cart and obtain the acceleration from the graph. 7. Repeat the steps 2 through 5 with a mass about 1,000 grams, adding to the cart and obtaining the acceleration V3 from the graph. 8. Calculate the theoretical values of A1, A2, and A3 using the equation using G equals 9.8 meters per second squared. 9. Compare your measured values of the acceleration with theoretical values and get the percent error.
Okay, now you've done this before, but you haven't done it where you're changing the masses. You've just done it with the cart and the pulley. So that's what's different here. So the first part where you just have the cart on the pulley and you're getting your delta x over your delta time, that is nothing new. You did that. But the part about adding the masses, okay, that is something new. So what we're doing is we're looking at, before we were just looking at velocity and acceleration. Now we're looking at how the force changes with mass. So they have here constant force. So What is the constant force? It's the 50-gram mass hanging over the pulley. So what we're doing is keeping the force constant and changing the mass. So you have 3 different mass situations, okay, but the force remains the same. So those are 3 different graphs. So 3 different graphs of your time versus your velocity. Now remember how you get your velocity? It's the same you did before. You get the delta x with your caliper, you divide by 0.1 in your time, and that gives you the velocity. You're going to have calculate the 3 theoretical values. I'm going to go through that in a minute. But you're going to get theoretical values, and you're going to compare those to your slopes. Your slopes are your experimental values of the acceleration. So the slope of the velocity versus time graph is going to be your experimental acceleration. So in the last lab with the projectiles, which you need to pass in this week, what day did we finish the projectile lab? Was it Monday? Anyway, let's just say you need to pass in that projectile lab. I think it was Monday. So you should pass in that projectile lab therefore tomorrow, but I'll give you one more day. So pass it in Wednesday. You got to pass these labs in. They're part of your grade, and they're 25% of your grade, so you have to be sure to pass in the labs. Okay. Now, just like before, you're going to get your delta x. Okay. All right. Now, let's talk about, those are your 3 experimental. Now, we're going to skip ahead right now, go to the next page to talk about the theoretical for this. So it has here A theoretical at the top, which is m1 divided by m1 plus mass of the cart times g. Now, notice underneath there, it says g is 9.8 meters per second squared, or 980 centimeters per second squared. So if you're using centimeters, your g is 980. You have to multiply by 980, not 9.8. M1 is your 50 grams that's hanging. Now, you don't have to put it in kilograms if you don't want to, because the units for mass cancel out. Since we're doing mass divided by mass, you can leave it in grams. MC is going to be the mass of the cart, which you're going to weigh on a scale, but when you change your masses, right, that's going to change that. So then you're going to get a percent error where they give you the equation, theoretical, which is coming from this equation, minus the experimental, which is the slope of your line, divided by theoretical. Now, why is this the theoretical acceleration? We haven't really covered that yet. That is a physics 2 subject. So right now you just have to take it that this is being told to you. This is the theoretical. It's on a little bit higher level than what we cover for physics 1. Then they don't give you the table like they did before. You have to make your own table. So you should use a ruler, make your table. They tell you what to put in the table. Delta t, which is always 0.1, cumulative 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. xi, which is your 7 distances. And the next cumulative, where you're adding those together, remember? You add the first you write down the first one, and then you write down the sum 2. And then vi, which is going to be your xi divided by delta t. Okay? Then you write down your vi. Then you have these 3 graphs, velocity versus time. So you're going to get the slope of those 3 graphs in part A. That's 3 slopes. Those are your experimental. So they have your slope is equal to A experimental. And then they have up here, your percent error is your theoretical. So for any remote students, you're giving all, the delta t is always 0.1. This is 0.1 through 0.7. They're going to give you these 7 xi, which is the distance from their caliper. You add together those. Here, this vi comes from the xi. You divide the xi by 0.1 to get your vi, and then you get, therefore, 7 vi's. And you graph them here. So you have 0.1 through 0.7 here, and then you have the 7 vi's, just as we did previously. This is actually our 4th lab. but it's just called lab number 3 because of we had one extra lab. Okay. Do you feel you understand the first part? Okay, now I think there's 2 out sick today, so hopefully they'll be back tomorrow. If they're not, this isn't a lab you want to do by yourself, so we would just have to change our groups. I think before we discuss the second part, what we're going to do, we have 8 minutes. We'll discuss the second part tomorrow. I'm going to have you take what you have there and put that back. Throw out your white post-it boards, put back your carbon paper, etc., and start to take out the lab equipment that you need. And then we'll talk about the lab board tomorrow. Okay, so just start putting it back. Put back that photo gate. Put them back in the right spot, please. Okay, so this is the end of the stream.